Alright, so in this video I'm going to talk about sketching the graph of some sinusoidal functions that have a couple different types of transformations that are going to happen to them. So the first one I got is y equals 5 times sine of x. So anytime we multiply or divide on the outside of our sine or cosine function or any other function, it's going to be a vertical stretch or compress. So when we talked about having the form of the equation a times sine of bx plus c plus d like this would also, we could refer to as like a change in this a value, and since it's a vertical stretch, it's going to change the amplitude of our function. So let's think about what our normal sine wave looked like. Our normal sine wave only went up to 1 and down to -1, and I'm going to draw that pretty small here because I'm going to go now and stretch up all the way to 1, 2, 3, 4, 5 and down to 1, 2, 3, 4, -5. But our original sine graph only went up to 1 and down to -1. So it started at 0, it went up to 1, down to -1, and ended back at 2 pi at 0. Okay? Our new graph of 5 sine of x is going to start at 0, 0, but it's going to go up to 5, down to -5, and back to 2 pi. So it's going to stretch up like this, and our amplitude is going to change to 5. Okay? Well, let's talk about multiplying on the inside of our function, and this time we'll talk about cosine. So if I am multiplying on the inside of a function, this is going to be a horizontal stretch or compress, and so what I'm thinking about is what we've been calling our b value if we're multiplying times a number on the inside of our sine or cosine function. So that's going to affect the period of our wave because we're horizontally stretching or compressing. Okay, so let's think about normal just cosine of x first. If I were to draw this, then I would draw normal cosine would go up to 1 and down to -1, and would start up at the top, go down to -1, and back up at the top when we hit 2 pi. Okay? If I want cosine of 2x, then let's find what our new period would be. Now if the period equals 2 pi over absolute value of b, and b is 2, then our period now is not going to be 2 pi, it's going to be 2 pi over 2, which gives us pi. So if we think if this is 2 pi, then that means the new period of our function, one cycle of our wave should end right here at pi. Okay, so if I've got pi over 2, 3 pi over 2, then we're going to start up here at 1, go down to -1, and back up to pi, back up to 1 when we reach pi. So essentially 2 cycles of our wave are going to fit within 2 pi. Okay, so this is what our graph would look like for y equals cosine of 2x, a rough sketch of that. Alright, down here at the bottom, what about y equals sine of x plus 3? Let's think about this type of transformation. This time we're adding on the outside. So if I think back of this form right here, that's going to be a vertical shift up or a change in what we call our d value, and it's going to affect the midline of our graph. Okay, so here we go. If I have our regular function used to go from 0, 0, 1, 2, 3, 4, 5. If it used to go up to 1, down to -1, and end back at 0 at 2 pi, our new function, this center is going to shift up 1, 2, 3. So we're going to be up here. Our amplitude is still going to be the same. We're not stretching anything, so it's still going to go up 1 and down 1 from this point. So our ceiling and our floor are still going to be just one above and one below. So it's going to look something like this. and it's still going to end right here at 2 pi. It's just going to be vertically shifted up. Okay? All right, last one. So first we've done a vertical stretch, then we did a horizontal compression, then we did a vertical shift. Let's talk now about what happens when I have y equals sine of x plus pi over 2. So I'm adding or subtracting this time on the inside. That would be a horizontal shift, left or right. Okay, so that would be if we had y equals a times sine of bx plus c plus d. This would be what we talk about as a c value, or a change in our phase shift. Okay, so if I have the normal sine function, our normal sine function would start at 0, 0, go up to 1, down to -1, and back to 0, and end at 2 pi. Let's split this up a little bit. This would be at pi, that max is at pi over 2, the minimum's at 3 pi over 2. So if I have a c value of positive pi over 2, we know that we can calculate our phase shift as negative c over absolute value of b, or negative pi over 2 over our b value is what's our coefficient of x, which is just 1. So we have negative pi over 2. So we're going to be going backwards pi over 2. So from this spot, if I go backwards, sorry about the bell, backwards pi over 2, I would now be starting right here, and I'm going to be finishing back pi over 2 as well. So you can either visually just move back pi over 2, or if you want to check that and calculate it, you can take 2 pi and subtract pi over 2. If I find a common denominator, that would be 4 pi over 2 minus pi over 2 is 3 pi.